Hello and welcome everyone. Welcome to a theoretical project 1 of group 4. I am 5 Nafis. My ID is 171011171. To add a robot, first we need to add the robot from base node. Under children, select the shape, then appearance to PBA appearance and set proper size under geometry section. Name the shape as body to use it in boundary. Enable physics and under bounding object, choose body for collision boundary. Now again under children section, add a hinge joint. Choose hinge joint parameter as rotational motor and endpoint as solid. Under endpoint solid, choose children and add shape. Also name it as wheel. Appearance as PBA appearance and under geometry choose cylindrical for wheel. Now adjust proper height and radius to make it look like a wheel. Adjust the wheel to attach the body properly. Drag and drop is an efficient way for it. Add physics and bounding object as wheel. Now wheel has boundary and collision. Now name the hinge joint as hinge joint 1 and copy paste it 4 times to make 4 wheels. Make sure to drag and drop the wheels in proper size with rotation. Now change the name of rotational motor to corresponding wheel number. Without proper naming, it will not work as the code intended it to. Also, it is very important to match the anchor point to translation of the wheel. Without matching the wheel, it will not rotate properly or will be very wobbly, meaning the wheels will not work as it intended. That's all from me. Thank you.
Assalamu alaikum, dear respected faculties. I am Jawad Hassan. After building our robot, we need to add distance sensor. We will add distance sensor from the children part and add a shape to that and give a PBR appearance. The geometry will be box shape and we need to change the color maintaining the contrast. We also need to change the metalness and change the translation, and keep in mind that our our distance sensor is not too small. We also need to change the rotation and scaling, and we have to do the same for another sensor and give the sensor's name. Left sensor will cover left and front part, and right sensor will should cover the right and front part. We can see the rays of sensor with the help of rendering. So we need to add a camera also and add a shape under children. We need to give PBR appearance and give a name to the camera. We need to change the scaling, translation and rotation. Camera should be in the front side. After these, we need to add the GPS, which will give us the original position of the robot. We need to add GPS from the children part and add shape, and also we need to maintain the translation, rotation and scaling for the GPS. That's it.
Assalamualaikum respected faculty. My name is Mohammad Abu Obaida Zishan. I will be explaining the controller part of the code. My ID is 18201214. So we have received this code from the Weebots website. So we are only providing the camera section of the code. Rest of the code was already there. We only changed them we only did some minor changes. So here in this code logic, the robot will keep going forward as long as it does not see any obstacle. As you can see here, the left speed and right speed is 1. As soon as it receives it detects an obstacle, the right speed will become -1. So the left part of the robot will go forward and the right part will go backward. So and then the robot, so that means the robot will keep going clockwise as long as the robot is detecting an obstacle. So here we can see if the obstacle detection is defined by getting a distance reading less than 950, so the obstacle counter is set to 100, and so in that way the robot will enter this if condition. So the robot will keep going clockwise as long as the obstacle counter is not back to 0. So, and then if the obstacle counter is 0, or if there is an obstacle, it will just keep going forward. So as we can see, the left and right speed is 1. So now I'll give you a demo of how it detects obstacles. Sorry, I mean shapes, how it recognizes the shapes. So as you can see, it is recognizing all of these shapes pretty easily. And now I will give you a demo of how the obstacle detection is working. So I will fast forward this. So see, it's going right, just as I explained. um, yeah. So thank you, dear respected faculty.